In this lesson, we will discuss an important property of continuous functions and present the intermediate value theorem. Let's look at the graph of this function f, which is continuous between -1 and +2. Notice a few points on the graph. At x equals 0, the function is at height -1. So f of 0 is -1. And if we look at x equals 2, the function is at height 5. So f of 2 equals 5. Now this is a continuous function. So if you were to draw this graph, there's no way you could get from height -1 up to height 5 without hitting every single height in between -1 and 5. As you trace the function from height -1 up to 5, you hit every single height between -1 and +5. So this is the consequence of a function being continuous. So the intermediate values are any value between -1 and 5. We know that for sure the function will hit every single height between -1 and 5 between x equals 0 and x equals 2. So since f is continuous between 0 and 2, the function f takes on every value between -1 and 5. Again, this is a consequence of the function being continuous. So now let's be more formal with the statement of the intermediate value theorem. If f is a continuous function on the closed interval from a to b, and y0 is some number, it's a number, a value that's between f of a and f of b. Okay, so let's think about this statement first. You have a closed interval from a to b. The function is continuous. That means you start the graph at a and you can stop at b without picking up your pencil. F of a, you can think of the height of the function at when x is a. And f of b is the height of the function, the graph of the function, when x equals b. The graph of the function starts at height f of a and stops at height f of b. Without picking up your pencil, then you must have hit every number in between f of a and f of b. So that's what the conclusion of the intermediate value theorem says. So if y0 is any value between f of a and f of b, then y0 has to equal f of c for some number c between a and b within the closed interval from a to b. So let's look at the picture that goes along with this theorem. So we see we have a continuous function between a and b. If you pick any value y0 between height f of a and height f of b, then somewhere the function will be at height y0. We're calling the x value at that point c. So the big idea is if a function is continuous and it takes on two values, then it also takes on all values in between. That's the main idea of the intermediate value theorem. Let's look at an application of the intermediate value theorem. We can use this theorem to show that an equation has a solution. Recall that a solution of an equation of the form f of x equals 0 is often called a root of the equation, or you could say it is a zero of the function f. So if we have a continuous function f and I have an equation like f of x equals 0, then the intermediate value theorem can be very useful to show that this equation has a solution. So how does this work? So if f is continuous and you can find a value where the function is positive. So for example, suppose f of a is greater than 0. So this means if f of a is greater than 0, then there's some point at x equals a where the function is above the x-axis. And if you can find a point b where the function is negative, then that corresponds to a point on the graph that is below the x-axis. So if you have a continuous function and it's above the x-axis at A and it's below the x-axis at B and it's continuous, then there's no way you can get from height f of A to height f of B without crossing the x-axis somewhere. Well, when you cross the x-axis, then the function has value 0. So somewhere between A and B, the function has a 0. Let's see an example of this. Let's use the intermediate value theorem to show that the equation 4x cubed minus 6x squared plus 3x minus 2 equals 0 has a solution. So I'm going to let f of x, my continuous function, be the polynomial 4x cubed minus 6x squared plus 3x minus 2. Now notice that this is a polynomial function, so it's continuous everywhere. So what we're looking for is a solution of the equation that is a number c such that f of c equals 0. So we want to find a number c with f of c equal to 0. Now I can use the intermediate value theorem if I can find a value of the function where the function is positive and a value of x where the function is negative, and then somewhere between there the function must equal 0. Notice that if I plug in 1 into this function, f of 1 equals 4 minus 6 plus 3 minus 2, which equals negative 1. So this is negative. And if I plug in 2 for x into the function, f of 2 equals 4 times 2 cubed, so 4 times 8, which is 32, minus 6 times 2 squared, so minus 24, plus 3 times 2, which is 6, minus 2, and this is a positive number. This equals 12, which is positive. So since f of 1 is negative and f of 2 is positive, and we know that f is a continuous function, by the intermediate value theorem, we know that there's a number between 1 and 2 where the function equals 0. So since f is a continuous function because it's a polynomial, the intermediate value theorem says that there has to be a number c between 1 and 2 such that f of c equals 0. So at 1, the graph of the function is below the x-axis. At 2, the function is positive, and so the graph is above the x-axis. And therefore, somewhere between 1 and 2, the function must have crossed the x-axis. At that point, that's the number c. That's where the function f of the function equals 0. So f of c equals 0. Therefore, the equation f of x equals 0 has a solution somewhere between 1 and 2. And that is what we wanted to show.